Collatz conjecture is a very simple rule that generates the next number. With any positive integer, you can start, and you just check these two facts here, if it's even or odd. If it's even, you cut the number in half. If it's odd, then you multiply by 3 and add 1. So let's call it col, and I will make a function of it. So this is nothing more than, you just check if the number is even, and then if so, then you just cut in half. If not, then you do 3n plus 1. So it's as simple as that. So you can come up with any number you want, say n equals 45. Then you can do n equals col of n. Then it will automatically assign. So you can keep running this here, which is kind of tiring. So the best way to do it is actually nest list, and in which you give the function which is col of the number, and you give the first number. In our case was 45. Then you tell it to go, say 100 steps here. Then you can see it going here. The conjecture is that I didn't say it here. It eventually reaches 1 here. So you could have some odd number, strange number I meant, like 27 that goes for a long time and without hitting 1. But if you let it go for a while, 110 times, then you see it hitting, well, I missed it just by 1 here. Eventually hitting 1 here. And in fact, it would be best to just use a nest while list. So it's the same as this here. So why don't I just rename it? Nest while list, in which the last one is not how many times it goes, but the condition in which you keep going. So when the number is not 1, you keep going. So when I do this here, you will see it ends in 1. See, I didn't have to guess how many steps it would take for me to reach. You will see no matter what number I give here, it ends in 1. Many numbers are short. Some numbers take a long time, but eventually they always reach 1. So that's the Collatz conjecture. And if I want to see the list, what kind of a path it takes to reach 1, you can do list plot of this list here, and it will look more dramatic when you say joined is true, like that. And then it looks like this here. So if I put 27 here, it's a peculiar number. It has a long list. Its top is being cut off here. So let me do plot range to be full. So it shows me the whole thing. It goes pretty high. Although it's just a small number, 27 here, it goes through all this time and then reach there. So if you want to say, let's take this part out here. On your research, I'm copying and pasting here. Let's call this A. If you want to know how many steps it took to get there, list A would tell you. Length. It took 112 steps to reach 1 finally. And if you want to know the highest number it ever reached, it is max of A. It went 9,000. So both could have some meaning to it, how long it would take to reach the top and all that. So let's see. This next while list that we have here. So I will call this to be a function here. So I have a Collatz function here. But what I will do, how should I do it? I will make a map of it. And then instead of putting this number here, I'm going to put one number at a time. So I will do range of 100. So I will make it start with the first 100 numbers. But you see right away that I cannot do this pound here because it doesn't know which pound I'm talking about here. So what you have to do is you have to make a function out of this guy here, a pure function out of this. So I'd like to show you here. It's a function of n which does this. I will copy and paste, and this is the n here. So now this is a pure function that would go through the whole thing for you. So let's call it COL2. It may get confusing, but here it is. So here, COL2. Now when I do COL2 of 27, I get this. that you were getting. So it is equivalent to sticking in the number here. Why are I adding one more layer here? This way I can map it, you see. So I can make this list with the first 100 numbers. Okay, so I will call it call_res as a Collatz result here. Okay, so I will get 100 lists here, each one going through the whole cycle here. So who took the longest? So we're gonna find the maximum of the length of each one. See, I gotta look at each one. Collatz_res, say 27th. I meant this is a list here, so I got a double bracket 27. Then it would be this here. So I can find length of it, all that, but this is acting as a, and I can find the maximum of each. So what I will do is I will make a pair. I will find the maximum of the list, and I will find the length of the list, of each list, and I will make it like this. Okay, and I'd like to know what the first starting number was. It was this here. Okay, so what I do is I will then map this guy, and then the list is, what did I name it? Call_res. Copy and paste. So when I do this here, I will get this here. Ah, I didn't expect the first number. Oh no, okay, I just want to know the first number, so I just have to do the 1 here. No, see, so call_res gives you a whole list, right? Like this here. But I want to know what number with what number I started. It was 3 here. So all I need is the first number, like that. So here, so when I start with 1, the maximum number I ever reach is 1, and it arrived at 1 in 1 step because it was there. It didn't take any step. So here 2, it takes 2 steps to reach back to 1, and then so on. You can see this here. So now let's call this res2. So suppose you want to know who took the longest. That would be, let's sort by second one, right? Res2. We are sorting res2. There are several ways to do it, but let's do it the right way. I want the second element to be greater than this way. I'm sorting it. The 1 and 2 means nothing more than coming the sorted lists, first element and second element, as in here 1, 2, 3, 4. So this says 1 and 2. So you got to read this #1, not #double. This is different. This is first element of the list. When you read this #1, you should read it as a previous and this next. So I'm saying the previous one got to be bigger than the next one. However, previous one has 3. See, res. Let me show you res. I will just show you first 3 of them. Each guy has 3 things here. So if I want to sort them, who am I going to look at? I'm saying it to look at the second guy. Second guy was the maximum here. So I will have the maximum number first here. So number 97 took 100, these many steps. So did 95. So did 94. Interesting. All these numbers took this number of steps, and others didn't, and one took the least number of steps. So this is the sorted by the number of the highest they ever reached. All of them reached 1932, which makes me curious. I will call this res3. Actually, I don't have to do it here. I could do it with res2. So what I will do is, out of res2, I want to see the maximum numbers only, which is the second one here. So these are the maximum numbers. You can see this 1932 showing up here several times. So what I want to do is tally it. So this, see, I can see how many kind of numbers I get here. So this 1932 that we saw is the most popular one. I didn't know. And others just show up once, but this number of steps is most common. Again, this one can be sorted too. So that I want to have a first one to be larger than the number that shows up second. Except, which one we want to look at, because we got 2 things here. I want to read by the second one. In other words, I want to see the most frequently appearing number. largest number first. So 16 times is the most, 12 times next, and so on. Okay, just with the beginning number, 101st beginning number, all this diverse conclusion is coming up, which is very interesting. Now you can easily see that we could have tried first 100 numbers here. So 1,000 numbers I meant, shall we? So we run that, and then we make a list of it. And then let's see what kind of things we have. 1932 is again, I thought that's what we had before, right? 1932, yeah. So even if you give a 1,000, a beginning number of 1,000, none of them goes above 1932, maximum number. That's very interesting. Very interesting. What if you have 10,000? Is there something wholly about 1932? Again, nobody. Am I looking at right? What is this? No, this is the most popular one, but there are higher ones too. Huh, okay, I almost got fooled here. I want to see what was the highest number. See, first number is the highest one. After I tally, this is the how many times I got. No, this is the number I got, and this is how many times I got. I had 2 here, so I was looking at the second guy, how many times it happened. So this is telling me the most frequent one, but not the biggest number I reached. Sorry. This time I want to look at the biggest number. Wow. All right. So much for that. So when I had 100 of them, let's get rid of this guy. Why don't I get rid of this and just merge them? Control Shift M. So when I did 100 of them, the biggest number was 9232, and that was the also happened to be the most frequent one too. But when I do 1,000 here, it reaches a quarter million. When I do 10,000, it reaches how high? 27 million. So you can see where the largest reaching number comes and how frequent it is. But nonetheless, when it comes to champion of the frequency, the number we saw before is still the champion, no matter where we start, right? Yeah, this 9232 is the champion. So this is the Collatz conjecture in its original definition here, and you can get lots of statistics and analyze it by following this. All the charts you see in Wikipedia is made out of this here. It all depends on how you plot them, and then you will get this here. So let me show you. Res2 is the result. So this is the beginning. So if I plot this versus that, okay? So now this is the starting number, and this is how high it went. I can plot that. So let me do list plot of, say, res2, where I will get only first 2 numbers, right? So I'm plotting, no, what I meant is all. From everybody, I'm getting only first 2 of them. So I get this. Remember seeing this in Wikipedia? Maybe this is too many, so I will do 1,000. I need not see it. And then plot it. There is the frequent number right there showing here. I wonder what number they used. Was it 100 that they used? It looks something like that. Was it even higher? Or maybe the top is being cut off. Plot range. Wow. So let's do just 1,000. So there are all just few oddballs, but the rest of them just stays here. Okay, so this is the maximum that they appear. What about how many times it took for them to arrive at the conclusion? So let's get the 1 1/3, right? How do I get that? I think I do 1 3. That way it will pair me. I got to make sure that I'm getting it right. So let's see. It's too many. So what I will do is I will do res2, first 3 ones. I will take a look. 10th through 12th elements here. of those, I will do Control L here to repeat the same thing. Oh, I got to do semicolon here. There we go. I got this here. So I want to associate 10, 7, 11, 15, 12, 10. So let's see if I can do it. From 10 and 12 here, comma. I think all I got to do is 1 and 3. 1 and 3. Like that. What did I get? 12 and 10. Did it have to be 1 and 3? Nope. Okay, I'll take the easy way out. I will call it res 3. Did I have res 3 already? Let's get rid of this guy. I will call it res 1, 3 because I'm using the first one and third one. And how I will make it, I will just make a table out of it. And I'm going to say I want the first one and third one. Actually, I first one and I third one, where I is res 2. Okay, so let's see, res 1 through 3. It looks like that. So if I got it right, it will be 1, 1, 2, 2, 3, 8. 1, 1, 2, 2, 3. So I got this here. So let's not see it. So let's plot this. List, plot, res 13, joined. Maybe I don't have to see it. Let's see. There we go. Looks familiar? So this is in Wikipedia under Collatz. So if I make, say, 10,000 here, and I should be able to generate this, and I think this is what they have here. So you can do research like this here. So I guess this is what I'm used to seeing. I haven't seen this before. So this is how you check the highest that it ever reaches, and this is how many cycles it has to go through to reach back to 1. At any rate, this is how Collatz was in its original form.